So, first new idea. Our focus today is on inheritance, on a couple more keywords, a little bit new vocabularies to get you through that inheritance worksheet. And we'll be utilizing inheritance. As you saw in your previous project, the Starfield assignment with the particle and the oddball particle. You'll see it again in asteroids, where we build different objects off a floater class. That's the generic thing. The spaceship, the bullets, the asteroids, all that stuff is related to one another. So we make use of inheritance there. So one of the new keywords you'll see when working with inheritance is this keyword protected. Protected works like private, but access is given to any class that extends or inherits from this class. And you'll see an example of it. So if you're thinking that objects need to access member variables, or like children need to access member variables of certain parents, if you extended certain classes, you may consider using this word. It's useful, but it's not on the AP test. So over here, we have a little code segment. Have a look through. At the top, we have our setup. Great. We'll come back to that since it creates instances of this cow and blue cow object. Inside the cow class, we notice there are two private variables, my type and my sound. Them being of the string class doesn't really matter that much. It just means we can include strings denoted by the double quotation marks in there. My type and my sound have the words cow and moo inside them, and you have two standard get methods for my sound and my type. Down here, some of the new stuff. Class blue cow extends cow. We see that extends keyword, so blue cow inherits from cow. Blue cow is dependent on the base class cow. And then a blue cow has its own constructor, or initializes my type and my sound to say it is a blue cow and it is so blue. So we go back to the very top. What do we think? Does this code execute, or will there be an error? We try to initialize and construct a cow, blue cow called C, and then we try to call C's getSound method. What do we think? Error or no error? Nice. There is in fact an error. Private variables down here, when we run it, it says my type and my sound are private to cow. It says that my type is not visible. So when it gets to here, right, get sound, wait. Yeah. So in this case, we're giving you an example of when you would want to use the protected keyword. If you do want to access the variables present inside the base class, right? Blue cow wants to access the variables from cow. You might consider using the word protected instead. So in this example, it does end up working okay. So you see, I'm so blue. So next set of ideas, inheritance and extends. You've heard me use these, and now we have some notes for you. So inheritance lets you write classes without duplicating code. So if a blue cow or blue cows are very similar to regular cows, then you would probably want to use the extends keyword, so you don't have to rewrite a lot of your code. And that's what inheritance does. It groups similar things together, like you and your siblings, you and your parents, and your family members. You're all associated with like the same or similar groups of people, yeah? That's what connects you all. Similar thing with inheritance in computer programming. So because blue cow is a cow, we could put blue cow in an array of cows. Does that sound familiar? Oddballs and oddball particles. Since an oddball is a particle, an oddball particle can be put into an array of particles. So overriding, you've seen this with, or actually, have you seen this? No, you saw overloading, like with constructors. You put in more input arguments, you've overloaded the constructor. Overriding is replacing. Like in the old Pokemon games, you overwrite your previous save, right? Very similar, overriding. Overwrite and override. So in your oddball particle class from the star field, you overrode the show function. You changed how it moved, you changed how it showed. Both those methods were overridden. So here's a quick example. You knew that particle has its own show class. Those are little circles of random color. But now your oddball is suddenly a rectangle. Oops. So one would say that the show method, the show function, is overridden. And more specifically, the oddball particles show class has overrode the particles show method. Jeez, it's such a mouthful. Questions, comments? All right, next up, we got a bunch more vocabulary for you. It's the beauty of object-oriented programming. Nice thing is you're familiar with most of these ideas, but now you have new vocabulary to adopt to represent them. So you have your classic oddball extends particle, right? So this thing, right, oddball here is a subclass of the particle class. The particle class is called the superclass. In more familiar vocabulary, oddball is the child, particle is the parent. Okay, so the last one I think is most familiar. You are children and you have parents. Sub and super. Super is the larger one, so that's your parent. Sub, I guess that's you. That's the smaller one, so that's your particle, oddball particle. And so this other one, I think you've heard me use this before. This is the base class, right? And then these are the derived classes. In order to derive something, you must start somewhere. And so where do you start? At the base, which is the particle. Thusly, you have these color-coded keywords up here. Super is the same as parent is the same as base. Derived, sub, and child all are linked in the same way. So as an exercise, I may just purposely interchange all these words with one another just to confuse you. And if you understand what I'm saying, then you understand what these vocabulary words mean. And of course, wouldn't be computer science without pictures of boxes with words in them and arrows. One of my college professors always joked that this is computer science doing these kinds of things. It's kind of funny how true that is. So if you want to represent it visually, you can use these arrows, and I think this may be assessed on the AP test. Or maybe it isn't. Maybe it was in principles where they assess you on these kinds of diagrams. What's weird is the arrows, it points upwards, and I want you to think about the arrow as asking yourself, is a, okay? Designates is a relationship. So here you would read this as an oddball particle is a particle. A subclass is a member of the superclass. A blue cow is a cow. Okay. It's weird. You would think sometimes like when I first thought about it, I was like, why does the arrow not point the other way? Like superclasses point to their children. No, no, no. Children point to their parents. So remember that is a relationship. It comes up often. Gosh. So one of the things you'll need for your inheritance worksheet is, okay, now that we have objects building on top of other objects, how do we know what type they are? So there's this useful function called instance of, and that functions just like the arrow does. It asks yourself, is blank a blank? So here, notice in, instance of, right? Instance of is like an operator, so that's like and, or, and not. It's also like add, subtract, and divide. So this word instance of goes between two objects. And then overall, this thing evaluates to being true or false. So here you ask yourself, is Bob an instance of thingy? And you take a look, okay. Bob is here. Thingy is the subclass. Or sub thingy is the subclass. Thingy is the superclass. Right, as denoted here, yes. So that means it's true. Here we ask ourselves, is Bob an instance of the sub thingy, which is the child class? They're like, okay, Bob, where are you? Bob, yep, you are in fact, so that's true. Then in this question, is not Bob an instance of sub thingy? Let's see. Bob is of the parent type thingy, so this one should be false. And then, yep, you see the output is false. Stare at it for a while, see where the things go. I hope the color coding helps you understand these relationships a bit. Parent and child, super and subclass. What's the other one? Base and derived class. I have to use that one more. Base and derived. Can you explain the first one? Why is it true? All right. So pay attention to these, specifically this one right here, right? Sub thingy extends thingy. So thingy is the parent, sub thingy is the child. Thingy is the superclass, sub thingy is the subclass. This is the base class, this is the derived class. So Bob is a sub thingy. You ask yourself, is Bob an instance of thingy? That is true. It's like, is Matthew an instance of the Wong family, right? That would answer true, because your parent has that last name. Make sense? Because of that inherited relationship, right? Cool. In your inheritance worksheet, we have an even more complicated class structure that's present. Notice here, we have the base class, pet. From pet, we derive the wolf and the cat. Then from there, the dog extends wolf, so it's building off a derived class. So this dog is a derived class. And then even more, you have a chihuahua that is derived from dog. So then you have this complicated class diagram. So a chihuahua is a dog is a wolf is a pet. Strange. It's funny because a decade ago I did this exact question. There was like a true and false question that asked like, is a wolf a pet? And I'm like, yes. And then Mr. Simon asked, do wolves make good pets? And I answered yes, and I got it wrong, and it was meant to be a joke, and he didn't give me back the point because I should have clearly picked false. I remember that a decade later. All right. So knowing these things over here, right? Based on this diagram, we can answer these two true and false questions. You have a wolf called Romulus, which is, what's it called? Calling the wolf constructor, and then you have a cat named Morris, also calling the cat constructor. Let's test our knowledge of instance of. We ask ourselves, is Romulus an instance of pet? True or false? Type it in the chat, please. This number 19. Is Romulus an instance of pet? Good, good. We see all the trues trickling in because right here you can see a cat is a pet. Remember to read the arrows, bottom going to the top. Is how you read the arrows. So cat is a pet. Nice. So 19 would be true. Now, what about number 20? Is Morris an instance of a wolf? True or false? Number 20 right here. Good. You see false. Because Morris is not a wolf. Morris is a cat. Very good. I see all the falses and lots of F's in the chat. There was a question. Do programmers usually write it out, or do they do this in their head? Well, with complicated diagrams or complicated programs, larger programs, one would map this out. They have books written on like how to organize all your objects. If you take a software engineering class, they talk about class diagrams even more. There is conventions to doing this, but for simple diagrams like these, and mostly for what you'll study for AP Computer Science A, it helps in the beginning to write things out, to organize it in your mind. Some can do it in their heads. I recommend that beginners write it out. So then you can focus on other things, yeah? It's like not a bad thing to write things down. There's this, when I was in teacher school, they talked to me about like cognitive load. And so you want to make sure you keep the things in your head that are that you need to, and then move the other things out somewhere else, right? Like onto a sheet of paper so you don't have to remember them. Like front-loading all the formulas for a physics test at the beginning, writing them all out, so then you don't have to spend brain power memorizing and keeping them in your head. You know they're on the paper, so you can focus on conceptual stuff. Cognitive load. So some more questions, right? Based on your inheritance worksheet, or you got like 3 or so more slides. So notice that you can put a cat or a dog or a wolf inside an array of pets because cat is a pet. So in this example, it demonstrates that. You have your wolf called Remulus, you have your wolf called Romulus, you have your dog, Scooby-Doo, you have your Chihuahua, you have a cat. And all of these can be now allocated or saved into a pets array. And it's because of this inheritance relationship, this derived relationship. All these objects, all these animals are pets. They're all of the base class type. They're all of the subclass. They're all of the superclass type. They're all of the parent class type. That's why they can be grouped together. And so, in this example, you have at the top, wolf extends pet, great. And inside the wolf class, you have get legs. So notice right here, Romulus.getLegs. Romulus is a wolf, correct? Yep, Romulus is a wolf. So 4 up here at the top would yield true. And Prince, square brackets 1. I think this one would cause an exception, right? Yeah. So then, because pets 1 here, although it's this, like, that's where Remulus is living right now, or Romulus is living right now, yes. Exception means you get an error and it won't run. Error, exception, very similar. Are they synonyms? I think. I'm not 100% sure. Well, that's the weird thing. Because when they're grouped into that array of pets, they're all treated as pets. They're not like here, pets 1 isn't specifically treated as a wolf. That's the odd thing. So you have to use where'd it go? So in this example, you have to cast it. If you want to use the getLegs method that belongs to the wolf class. Although they can be grouped together, right? You can treat it like a pet, but with the cast, you need to say, okay, specifically, you're a wolf now. I want you to call your wolf's like getLegs method. And you'll see more examples of this when we get to asteroids, but I think for the inheritance worksheet, you need to know that. the pet method doesn't have get legs. That belongs to the wolf class. So you have to use a cast. And this next part over here, we have, what is the point of this slide? Let's see. Okay. So focus on these words, and then we'll make sense of this code up here. So you can treat a Chihuahua as if it were a dog, wolf, or pet, but it doesn't work the other way around. You can't treat all pets as Chihuahuas. I think that lines up with our common sense. All right. Chihuahuas count as dogs, they count as wolves, they count as pets, but not all pets are wolves, not all wolves are dogs. Not all dogs are Chihuahuas. Does that make sense? It's why the arrow doesn't point the other way. It's not a double-headed arrow. When you read it out loud, it makes sense. So then here, right, dog equals new pet. So here, Pete is a dog. Will this be true or false? Does it cause an exception? 13 down here. Okay, so maybe I'll talk through it a bit. Pet here, right? So that's the superclass. Dog on the left-hand side, that is a subclass. So 13 matches this problem up here. Remember, it says will cause an exception, so it's like true that it causes an exception. If you type false thinking that false matches with like causes an exception, that's how the true and false question kind of got you, right? Does that make sense? I think you were thinking the right thing and then answered the true and false question wrong. I'm pretty sure. Yeah. So let's try that again, right? So specifically, number 14. Pete is a pet. We're trying to put a dog into there. This will cause an exception. True or false? Yeah, there we go. Yes, and this one is false because it doesn't cause an exception. That second layer of reasoning. Okay. So that's it. You can now begin a large part of your inheritance worksheet. I have to tell block 1 to watch this specific video. We'll take the time now to ask questions. If you have on vocabulary, you can take a peek at this inheritance worksheet, start working on it. We got like, what, 7 more minutes? But that's all I have to tell you. So formally, you can all go at this point. I have no more talking. I'm going to stop the lecture video.